The hyrax is one of those animals whose appearance tells a deeply misleading story. At first glance, it looks like a small mammal of no particular significance, something vaguely rodent-like, almost forgettable. In reality, it belongs to one of the most unexpected branches of mammalian evolution. Its closest living relatives are elephants and sea cows. That sounds improbable, only because the modern hyrax hides a much deeper history than its appearance suggests. The few species that survive today are the last representatives of a lineage that once formed part of a much broader African radiation of mammals, one that would also give rise to elephants and sirenians. To understand why this small and rather unassuming animal belongs to such extraordinary company, we need to begin with what a hyrax actually is. Modern hyraxes are small herbivorous mammals found in Africa and parts of the Middle East. Some live among rocky outcrops and cliffs, others in woodland or forested habitats. They are social, alert, and surprisingly vocal animals, capable of producing a wide range of calls. Their bodies are compact, their tails are almost absent, and their faces often give the impression of a generalized small mammal, the kind of animal most people would instinctively place somewhere near rodents, rabbits, or marmots. That instinct is wrong. Hyraxes are not rodents. They are not lagomorphs. They are not close to guinea pigs or rabbits at all. Instead, they belong to the order Hyracoidea, and that order sits within one of the strangest major branches of placental mammal evolution, Afrotheria. Afrotheria is a deeply important group of mammals whose early history appears to have been closely tied to Africa. It includes a remarkably diverse set of forms: elephants, sea cows, aardvarks, elephant shrews, golden moles, tenrecs, and hyraxes. At first glance, these animals seem too different to belong together. Some are tiny insectivores, others are giant herbivores. Some burrow, some swim, some walk on huge columnar limbs, while others hide in rock crevices and move across stone surfaces. For a long time, few zoologists would have placed them in the same major lineage based on appearance alone. That is one of the clearest lessons of hyrax evolution. Outward similarity is not always a reliable guide to deep ancestry. Within Afrotheria, hyraxes belong to a smaller and more tightly related group known as Paenungulata. This clade includes three living branches: Hyracoidea, Proboscidea, the elephants, and Sirenia, the dugongs and manatees. So when we say that hyraxes are closely related to elephants and sea cows, this is not a vague or distant connection. It reflects a real and well-supported evolutionary relationship within one of the most distinctive radiations of placental mammals. If hyraxes are so closely related to elephants and sirenians, why do they look so completely different? The answer lies in divergence, specialization, and time. The line that led to elephants moved toward gigantic body size and a highly specialized terrestrial herbivorous lifestyle. The line that led to sirenians became fully aquatic, adapting to slow movement and herbivory in rivers, estuaries, and shallow marine environments. Hyraxes followed neither of those paths. They remained relatively small and in time became specialized for very different ecological roles, especially in rocky or structurally complex habitats where agility, caution, and secure footing mattered more than size. That small body size, however, can be deceptive. It makes modern hyraxes look like minor mammals, as if they were simply one more group of generalized herbivores But the fossil record tells a different story. The living Hyraxes are only the final remnants of a lineage that was once much more diverse. In the Paleogene, especially in Africa, hyracoids were more numerous, more varied, and ecologically broader than they are today. Fossil relatives of modern Hyraxes occupied a wider range of body sizes and probably a wider range of diets and habitats as well. The modern rock Hyrax and tree Hyrax do not represent the full potential of the group. They are survivors of a much older and richer evolutionary history. This deeper history matters because it helps explain why Hyraxes seem so evolutionarily misplaced when viewed only in the context of the modern world. We are not looking at the full radiation. We are looking at what remains after a long process of diversification, specialization, and extinction. And once that is understood, the relationship between Hyraxes, elephants, and Sirenians becomes easier to accept. Their modern differences are enormous, but those differences are the result of long and separate evolutionary trajectories from a deeper common ancestry. Hyraxes are not failed elephants, nor are elephants simply enlarged versions of something Hyrax-like. Both lineages underwent extensive specialization. The same is true of Sirenians. What unites them is not superficial similarity, but shared ancestry within Penungulata. That ancestry is reflected not only in molecular data, but also in aspects of anatomy that made Hyraxes difficult to classify, even before modern phylogenetics clarified the picture. Their dentition, parts of the skull, and several internal features never fit comfortably with rodents or lagomorphs. The more closely zoologists studied them, the clearer it became that their true relationships lay elsewhere. The modern Hyrax also shows its own very specific specializations. Rock Hyraxes, for example, are extraordinarily well adapted to life in steep and uneven terrain. Their feet are not built like simple paws. The soles are moist, soft, and rubbery, helping them grip stone surfaces with remarkable effectiveness. Combined with a compact body and excellent balance, this allows them to move across cliffs and boulders with a confidence that seems disproportionate to their size. In ecological terms, they occupy a niche that rewards caution, agility, and close familiarity with shelter. Their sensory and social behavior are also more sophisticated than their outward appearance might suggest. Hyraxes are vigilant animals, often living in groups that depend on alarm calls, social communication, and access to refugees. Even the vocalizations that have recently made them famous online are part of a real and functional behavioral repertoire. On the internet, those sounds are treated as comedy. In nature, they are tied to social structure, territoriality, alertness, and reproductive behavior. This contrast is part of what makes the Hyrax such an effective animal for telling a broader evolutionary story. The meme gives people one image of the animal. Evolution gives us another. The meme presents a small, absurd, screaming creature. Evolution reveals a deeply distinctive Afrotherian mammal, one whose lineage is bound to elephants and sea cows by ancestry rather than appearance, and whose modern form represents only a narrow surviving fragment of a once broader history. That larger history is what makes the Hyrax so interesting, not simply because it became a meme, and not simply because it is related to elephants, but because such a small and easily underestimated animal preserves the history of one of the strangest branches of placental evolution. Behind its modest appearance lies a lineage tied to the deep history of Afrotheria, and to the same broader branch that also gave rise to elephants and sea cows. In other words, the strangest thing about the Hyrax is not the sound that made it famous. It is the ancestry that the sound almost distracts us from seeing.